For our last look in section 1.2, I'm going to look at number 27, investing. And this deals with percentages. Now, percentages by definition are a rate, but they're unitless. So our units aren't readily apparent in them. A lot of things we will develop as we go on translate into the decimal part of a percentage or a ratio directly. Sines and cosine functions do that. The exponential function will do that for certain values. And so we look at these things as being rates in terms of whatever the original thing was. And so for an investing problem, the percentage per year is the amount of money back per year. And so you give it money, you multiply it by the percentage, and that rate gives you money back. And so one of the things we have to look at with percentages is when we get them in their decimal form, they become unitless. And we'll see that as we look at this. So we have Ashley has $120,000 to invest and decides to put some in a CD that earns 4% interest per year and the rest in a low-risk stock that earns 7%. How much did she invest in each to earn $7,800 interest in the first year? And so I'm going to get that over here and come down to my display here. One of the things that you'll sometimes be given is that your interest, giving an interest formula. The interest equals the principal times a rate times time. As we have the amount of money you put in the percentage per time and how much time. Of course, I say put in, this also happens in reverse. You take out a loan and you owe more money due to interest accruing. So in this problem, we have a principal for two accounts. And so again, talked about the interest problem, but I'm going to scroll up here and we're going to look at this problem. And so again, we're looking at 27 in the book. She's investing two ways. So I'm going to put the principal into a CD. So I'm going to put P with a little c by it. And the principal into a stock. So I'm going to put P with a little s behind it. So I'm talking about principles, but I need to know which one is which. And I'm just going to give a little p to the principal with CD. Now, the total money she has is $120,000. So if these two things add together for $120,000, we subtract the two. And so when I add these back together, I get my $120,000 that she initially has to invest. Told you that trick of mixing things comes up a lot. When you know the total, but you don't know the individual parts, you can make a working relationship between the individual parts. All right, so I'm just going to say here that this is at 4%, and this is at 7%. So if I were to make two little interest equations out of these, again, I'm keeping this down in my thought process here. The interest for the first principal would be P times the rate. Now we're going to put the rate in decimal form. And so when we take a percentage to decimal form, we move the decimal place 2 to the left. Well, we divide by 100. And so 4% sits in the hundredths place. And then the time, well, in this case, 1 year has passed. And so that's the interest we would gather from just the CD. From the stock, I have 120,000 minus P times 7% times 1. And anything multiplied by 1 is itself. I ran out of space on my side blackboard here, so we're going to use the fact that anything times 1 is 1. Now at the end of the year, the addition of these two interests gives her $7,800. So if I add this and this, that's the same as if I add both left-hand sides, that's the same as adding both right-hand sides. So I can construct one equation using these two. Now I want to pull all my numbers to the front because we like them as coefficients. So 0.04p coming from this interest plus 120,000 minus p and let's do the same thing. Let's put our percentage out front. So we have coefficients out front. This will look a little tidier. 2, 3 minus p. So I add these two together. So the interest from the CD is this first term. The interest from the stock is this second term. Right, that's this here. And this is this bit here. But we add these together and we get the $7,800 she makes in that year. There's a couple different ways to do this. We can multiply by 100 to get rid of the decimals. We'll be dealing with some very big numbers. I'm going to keep the decimals here. You know, in the previous chemistry mixing example, I multiplied by 100 to get rid of decimals. In this case, I'm going to keep the decimals here. Both are valid, and because I multiply one side by that 100 and I do that to the other, they are the same quantities. So I need to run over to my calculator and I need to multiply 7 hundredths times 120,000 to get the first term here. So that's 8,400 minus 0.07p equals 7,800. I want to collect like terms. So 0.04 minus 0.07. So collecting like terms, I'm going to bring my p's together, right? This term and this term are going to combine, and that gives me negative 0.03p. That is indeed a 3. Control star. And I'm going to bring this term and this term together. So I'm going to subtract 8,400 from both sides. And that's negative 600. Alright, so to solve for p, I'm going to divide by negative 0.03. I'm going to divide both sides by negative 0.03. negative 0, 0, 3. My pen went a little bit wonky again, so I'm just going to slow down a bit. Last time slowing down a bit helped it up. So on this side I'm going to get P. Again, a lot of these money problems with the interest rates on them, your calculator is going to be your friend. And so negative 600 divided by negative 0.03 equals 20,000. And so it looks like she invested 20,000 in the CD, but in the stock, she invested 120,000 minus P, or 100,000. So $20,000 in the stock, and 100,000 in. Oops, I'm saying it backwards. Of course. So I'm fighting with the pen. That's in stock. Let me get my big eraser out here. But that's life, right? We can make mistakes and correct them. So in CD. Because P was the CD. And so she's able to invest her 2 lumps of money to get her return. And that is an investing problem. And again, an application of how rates and the units and rates apply